will be looking at the periodic table. The what? The periodic table. We shall be looking at what? The periodic table. And from the previous background, I do believe in O-level chemistry, you looked at what is a periodic table. And by definition, a periodic table is a list of all elements in order of increasing atomic numbers, giving their names and symbols. A list of all elements in their increasing atomic numbers, giving their names and symbols. Giving their names and symbols. Giving their names and symbols. The periodic table is defined as a list of all elements in their increasing atomic number, giving their names and symbols. If I'm to show you an example of a periodic table, you can go and look about it. It is something like this. I believe you remember it from, it has gone off so bad, but I'll get copies and then I come and attach. We're unable to print. There's a little bit of a problem. So after knowing that the periodic table is a list of all elements in their increasing atomic number, giving their names and symbols, what do we follow by? And what do we mean when we say atomic numbers? Elements in their increasing atomic number. So atomic number is defined as the number of protons in the nucleus of an atom of an element. A quick one. Atomic number is the number of protons in the nucleus of an atom of an element. Of an element. And we know that protons are the positively charged ones, and then electrons are the negatively charged particles. And the number of protons is always equal to the number of protons in an atom, because an atom is neutral. And for that atom to be neutral, that means the positive and the negative have to balance. So the number of protons in an atom is always equal to the number of electrons in an atom. And the original form of the periodic table was first put forward by Mendeleev in 1889, when he arranged elements in order of increasing relative mass. When he arranged elements in order of increasing mass. The periodic table was first put forward by Mendeleev in 1869, by Mendeleev in 1869 when he tried to arrange elements in their order of increasing atomic mass. So which means the father of the periodic table, we called him Mendeleev. And he tried to come up with the periodic table. That was in 1869 when he tried to arrange the various atoms, the various elements in order of their increasing atomic mass. And what does the term atomic mass mean? This refers to the sum of protons and neutrons in the atom of an element. Atomic mass refers to the sum of protons and neutrons in the nucleus of an atom of an element. That is how we define the atomic mass, which is the sum of protons and neutrons in the nucleus of an atom of an element. Because we know the nucleus is found within an atom makes up the element. So this grandfather of the periodic table, that is Mendeleev, in 1869, he tried using the sum of protons and neutrons to arrange the various elements, that is in their increasing order of atomic mass. Then as he was arranging them, he came up with what we call periods, and then the group. So we have the elements fall into 8 downward arrangements. The elements fall into 8 downward arrangements. And how do we call these downward arrangements? We call them groups. The elements fall into 8 downward arrangements called groups. That is the one that goes downward. While those elements again, because once we have the downward, then we should have also the across movements, the one which is horizontal. Then the elements fall into 7 horizontal arrangements. 7 horizontal arrangements. And how do we call these arrangements? We call them periods. Called periods. We call them periods. And going back to the downward arrangement, which is called the groups, they are numbered from 1 to 8, and those are referred to as the short periods, while those that are up to 10, they are numbered as the long periods. The groups are numbered from 1 to 8, and they are numbered from 1 to 8, and they are referred to as short periods. I beg your pardon, short groups. They are referred to as the short groups, while long groups are numbered up to 10. So the short periods are numbered from 1 to 8, while the long periods are numbered from 11 to 18. That is how they are numbered. Whereas those elements that are then the periods are numbered. The periods are numbered from 1 to 7. The periods are numbered from 1 to 7, yes. And the periods containing, if we say period 3, you'll find that almost all elements in that period are behaving in a given kind of way. While when we say that a group, for example, group 1, you will find that group 1 elements have almost similar characteristics. The periods, I beg your pardon, are numbered from 1 to 8, and they are referred to as short periods. It is not groups. So we are going to have a simple layout, but I'm not going to draw the complex one, because if I'm to draw the complex one, then we shall end up sleeping here. Let me rub off this. So we have said that the periodic table has elements, and those elements are arranged according to their atomic number, and they are arranged into groups and into periods. I'm trying to draw a sketch of a periodic table. So we said that those downward arrangements are referred to as groups. So these are the downward arrangements we are referring to, and we call them groups. So when I say a group, you know that that is the downward arrangement of elements. So this is a sketch of a periodic table. So what I have drawn, they are the ones referred to as groups. They are referred to as groups. Yes. So this would be our group 1. This would be our group 2. This would be our group 4. Group 3, group 4, group 5, group 6, group 7, and group 8. Because we say that those downward arrangements are arranged or are divided into 8 downward movements. So this becomes our group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. You find that elements in group 1 behave in a same way. Elements in group 2 behave in the same way. Elements in group 3 the same. 4, 5, 6, 7, and 8. And these ones are the one we call inert or noble. For them, they have an outermost shell which is very full, and they are very stable. So now when we are to start putting in what we call periods, would have this one here, then this one here, because it is a Henry has little brothers but can not.
I'm forgetting, but I remember there is a song, Henry has little brothers but can not organize for night studies. May all sleep peacefully since children are passing chemistry. So we stop from here, the one you studied in O level. So you'll find that
you'll find that these are the normal elements, and then we have these ones we call the transitional elements. So this would be period 1, period 2,
3, 4, 5, 6, and 7.
So the ones here are the ones we call the transition elements, and most of them are metals. So as we said, these are the group, and then these are the periods. So period 1, 2, 3, 4, 5, 6, 7. Group 1, 2, 3, 4, 5, 6, 7, 8. That one is a sketch of a periodic table. It is not the whole periodic table. And as we say that these elements, because they belong to the same group or the same period, they have a tendency of being the same. They have things that are kind of common. It is like you find your mother's children are all either tall, or they all have big bums, or they all have beautiful eyes. So you find there is a kind characteristic that all of you have in common, just because you belong or you come from the same place. So that takes us to the variation of physical properties in the periodic table. The variation of physical properties in the periodic table. The variation of the physical properties in the periodic table. Because when we say that physical, that means that it is something that is there for a shorter time, and after some time it would go back to its original shape. Then when we say property, it is what you possess of. So we are going to look at those changes that can be there for a shorter time that periodic table possesses, that the different groups, the different periods do possess. And the first one, these ones in short, we would call them the periodic properties. The periodic properties. What the periodic table owns. The periodic properties. And the first one, we have what we call atomic radius. We have ionization energy. We have electron affinity. Atomic radius. We have ionization energy. We have what we call the electron affinity. Electron affinity. We have what we call the electron negativity. The electron negativity. We also have what we call the electron positivity. The electron positivity. Then we have what we call the melting and boiling points. The melting and boiling what? And boiling points. So these are the various properties of the periodic table. So we are going to look at how does atomic radius vary across the period and down the group. We will see how does ionization energy. We will see what is ionization energy. How does the ionization energy vary across the period and down the group. We will see how does the electropositivity, how does the electronegativity, how does the boiling and melting points, how do they vary as we move from the element that is at the top in the group to the element that is last in the group. And what about the element that is first in the period and the element that is last in the period? Because as we have said, people from different families behave differently and they are affected differently. So the same applies to the periodic table. These periods and the groups are affected by different properties in different ways. So we are going to start with the